Figure below shows a 2-inch diameter solid steel cylinder that is built into the support at C and subjected to the torques T sub A and T sub B. 1. Determine the maximum shear stress in segments A, B, and BC of the cylinder, and 2. Compute the angle of rotation of end A. Use G, or modulus of rigidity, is equal to 12 times 10 to the power of 6 psi for steel. First, we write our given. We have the diameter, which is 2 inches, and G 12 times 10 to the power of 6 psi. What is required for us to solve is the maximum shear stress in segments AB and BC. And also, we are to compute the angle of rotation. Now, this is our first example for torsion. As discussed in the lecture video, in order for us to know whether that torque is positive or negative, we have to follow, or we have to use what we call the right hand rule. If it follows the natural, if the direction of your twisting force follows the natural curl of your fingers, then that is positive, and otherwise it is negative. And of course, our structure must maintain equilibrium. Still, it is just the same as what we had in the analysis of strain. For the elongation, it will be just an algebraic sum. So it has to be that for this example, we have two torques A and B. It must be that the total resulting torque would be enough for, in order for the entire moment summation for this system is 0. So for example, if we are to start from A here, A to B, B to C, right? As provided in the given, T sub A is 900 pound foot. Okay, and it follows, and the way to do the right hand rule, it must be that it is as if you cut a surface and you place your surface no, you place your hand on top of the surface, and then you try to curl your hand. If it follows the natural curl, then it is positive. So for this example, if we put our right hand on top of the cross section of our tube, and then if we do curl our fingers, if you can notice that T sub A indeed follows the natural curve of our hand. So therefore, T sub A here is positive. Okay, it follows the natural curve. And if you can notice, if it's 900 is positive, and if let's say we cut another section where T sub B is located, if you can notice, T sub B did not follow the natural curve of your hand, so 400 is negative. And if you can notice, since 900 is going follows the natural curve, 400 is the does the opposite. So it must be that to maintain equilibrium, it must be that the T sub C, or the torque at the rigid portion, must be 500, so that the entire torque that did not follow the natural curve will also be equal to 900. Okay. So, also one thing to remember, that we have to be consistent. So if let's say, if we our analysis started with point A, then everything that follows the natural curve from point A is positive. So AB from the right, to from A to B to C. That is along the x-axis there. Okay, so if we do moment summation along the x-axis is equal to 0 to maintain equilibrium, and therefore, okay, is equal to 0. Therefore, AB is equal to the value of T sub A, and T sub AB is equal to 900 pound-foot or pound-feet. Now we do our free body diagram at segment BC, still from the right. Again, we have to be very consistent. Copy. T sub A is 900. And then T sub B. So everything is very straightforward. The analysis is the same with what we did with analysis of strain. But nevertheless, the thing is, there is another concept that is being introduced. Because if you can recall, the analysis of strain involves summation of forces. But this time, when we do torque, we do summation of moments. But basically, the analysis is the same, wherein we cut a portion in between the two forces within the segments, and all that still the same. So if you do, going back to the video, summation of moment is equal to 0 following the right hand rule. So therefore, TAB is positive. M- B, no, A is positive, T sub B is negative, and T sub BC is negative. So therefore, we substitute T sub BC is T sub A minus T sub B. That's 900 minus 400. So T sub BC is equal to 500 pound-feet. Now, please be mindful. Although the resulting value of your 500 is positive, but again, remember when I said if we do force summation, if we do moment summation, if you say, let's say, some going to the right for summation of forces is positive, and if the resulting answer is positive indeed, so therefore the unknown force is indeed going to the right, right? So meaning, it is you initially you assumed the possible correct direction, but nevertheless, when you guys did the actual summation, you ended up with a positive answer. It simply means that your assumption is correct, wherein it is indeed that force is going to the right. It is indeed going to the right. Now for our case here, we ended up with a positive value for 500. It simply means that the direction we assumed for B sub C, which is which is clockwise, is correct. But nevertheless, if we do follow the concept of assuming for the analysis wherein we use the right hand rule to signify whether the torque is positive or negative. If you can notice, your T sub BC is clockwise, and that did not follow the natural curl of your right hand. So therefore, your 500, when you do later on, when we solve for the angle of twist, the 500 is actually negative. Now, since we are asked to solve for the maximum shear for the individual segments, so we know that the formula for shear is TR over J, right? And then J is For the value of j is pi over 32 d to the fourth for in terms of diameter, and pi r to the fourth over 2 if it is in terms of radius. Okay, so the calculated torque is 900. The radius is, it is given above, is 1 foot, right? So that is why we have to multiply that by ano, a diameter is 2 inch, so 1 inch for the diameter, for the radius, but our 900 is in pound feet, so we have to convert foot into inches, so that is why we have to multiply 12, and then you do the calculation. So your stress at AB is 6,875.49354156988 psi. Now for BC, the stress is 500 for the calculated torque. Still the diameter, the radius is 1. We multiply again with 12 to convert foot into 2 inches, and then still the formula for our J for circular area is pi over 32 times the diameter to the fourth power, which is 2 to the fourth power. And our BC is equal to, stress at BC is 3819.71863420549 psi. Okay? Again, don't forget to box your final answers. Now, for the angle of rotation, please bear in mind that if there are numerous torque being applied for a given for any given material, in order to calculate for the angle of rotation, basically angle of rotation is just the algebraic sum of all individual angle of twists. So basically for every torque, for every twist, there is a corresponding angle of twist, right? So for AB, it has its own TL over JG. For BC, it has its own TL over JG also. But for the corresponding angle of twist of the entire material, you just have to do the algebraic sum. That is why it is important to know whether the torque with respect to your reference point, which is our, for this example, is A, we have to know whether that torque follows the natural curl of your finger, or does it follow the right hand rule or not. Because if it does follow your right hand rule, therefore it is a positive torque. Otherwise, it is negative. Oh yeah, uh, it is quite unique for this example only, since it is made up of the same material and the same dimension, which is in terms of the diameter. Therefore, we can opt to uh, combine JG together, because basically if you don't want to combine them, still okay. Okay, so individually still okay. But nevertheless, if you want to make some uh, room for your calculation, especially if you input individual JG together for AB and then another JG for BC, it will take some time. But nevertheless, if you wish to do to solve it individually, still okay. So for the torque, this is 900 times the length for of AB, which is 5. And again, the 12 there is to convert uh, feet to inches. Okay, so I would just like to make some corrections. I believe I will be making some corrections later on. For the 12 in the numerator, it will be squared, because 900 is in pound feet, right? And 5 is also in feet, therefore that's feet squared. So therefore, we have to multiply 12 by itself. So 12 squared. Also, just some correction. It should be there. I made corrections already. Diameter should be raised to the fourth power. Okay, I'm making some corrections now. There you have it. It has to be 12 squared, 12 inches squared. So if you input everything in your calculator, your theta with respect to A is equal to 0.04583662361 radians. Now, as provided in the discussion, whether it will be in SI or in English or in the US customary units or the US customary system, all of your the answer for your angle of twist is always in radians. Okay, because everything will be cancelled out. Okay, so the answer for is always radians, but you can always report in terms of the two units, convert radians to degrees, but there are certain problems wherein they opt you to report your final answer in degrees. Good. Okay? But again, there are cases wherein radians is acceptable, but most of the time, it is always in degrees. So again, just a clarification here. Why is it that I multiplied again with 12? It's because, like I said, 900 pound feet and 5 feet. So I have to multiply it by 12 twice in order to cancel feet twice. Okay, thank you.